My name is Robert Fekete. I work at Volvo Cars. I am trying, or will try, to talk to you about the challenges I experience daily, the possibilities, and for us as a community to better understand things that is happening in the automotive realm when it comes to actually deploy software, actually work with software, and mix classic versus modern, because that's where we are bridging. And what Daniel told Eclipse STV is looking at that bridge, but there is more to it. Just a disclaimer, I mean, it's my views, guys. Not necessarily my employers, but we try to make it our employers' view. My history, we can skip it through fast, but it started actually bricking my manager's iPack with Pocket Linux 2000. Then it went on from there. In 2007-ish at Ericsson, we did a fantastic job introducing Linux. Linus Valet, who was here before, booted up a core. I entered as a multimedia person with display, graphics, and cameras. And that was the super fun. That's when I learned most of my parts. And we learned to make embedded. Linux wasn't embedded 2007-ish. It became that through a lot of work from us, from others, like memory management, no copy, etc., etc. I've been involved in Android a lot, working almost solely with the GPU drivers, display engines, blitters, you name them. And at Intel also, with Hans. That's when we started the Linux conference you are at. So it was a great time there as well, more drivers. And now I'm at Volvo Cars, trying to promote open source, Linux, and try to get the bridge between computer science, classic, to merge. And it's a challenge, and we will notice and come to this. But some great news is that since last year, there is an open source program office. And that's great. We can thank Carl-Erik Mols, who sits there, for driving it, former head of Sony's open source department also. So things are moving. The attention is there. Now we just have to need to join STV and ELISA. You know, we are working on it. Bear with us. It's an automotive company. Things are not that fast all the time, but it's going. It's acknowledged. It's part of the business, or we want it to be, because it is. So let's make something good out of that. And before we continue, I just want to bring up this guy. We owe him a lot, all of us. Niels Bolin. He invented the 3-point safety belt. Turned out to be a lifesaver, deluxe. What Volvo Cars did back then, not 59, but a few years later, was actually to open source that patent. Give it away, so everyone could benefit and be safer in traffic. And that is a mentality I think we should push for, or try to push for as an OEM. And why not us? So let's try to live on this. We are all into this. Traffic is not safer than the weakest, worst car, so to say. So we need to make all of them as good as we can. There is no place for inventing everything over and over again, because that's what I see, and I don't feel safer because of that. Perhaps old times, but not in the new modern big system on chips that we are experiencing. So let's keep ensuring that everyone is safer, not only one car company. So before we look forward, we might look how it was before. We talk about software-defined vehicle. That's another thing we noticed, that cars has actually been since 79 or something when the first engine control module got software. And forwards, it's a lot of software in cars. Last 10, 15 years, it's shitload of software in the cars. So why the buzz of software-defined now? When it has been software for, I don't know, last 20 years a lot, is perhaps that it's becoming more, how to say, aware of OEMs, more aware of the communities, that it is actually software that was hidden everywhere, gets up to the surface. And that could be a really good thing for getting more eyes onto it, which would lead to better, what I would call safety. Daniel explained it a little. In the past and now, we have small MCUs, ECUs, as you said, microcontroller with a function. And now comes the naming conventions. In automotive, it's the function. When we talk a function, it's probably, you know, static void something. No, it's a function here is a seat, massaging the seat is a function. Lights is a function. That the steering wheel steers the car is a function. So it's on that level. So when we as embedded comes in, talk about functions, misconceptions immediately. The same when we say software versus hardware. When classic auto says hardware, it's something with a physical dimension. You mentioned it. It can be screwed to a hull or some chassis. It has connectors. That's it. That's hardware. Or the metal. And now we get confused by me because I also worked with metal, which was the graphics drive, low-level API. So if you say metal, people get confused. Not to mention rust. I don't know, Julius, if you have problems with that. People try to get rid of it. Then we came here, guys, we should have rust in the cars. And half of the managers think, no, for fuck's sake, kill it. And it's like, no, please, no, it's software. So
make it worse, the name comes from a fungus.
perfect. Yeah, wonder, no fungus, please. So it's a lot of conventions that mixes up. Hardware, software is not what hardware software is for us. For us, hardware is a PCB with a circuit board, with a MCU or a SOC, so on and so forth. So sometimes the guys in the classical mention things that we know as software, but we're not even talking about the same things. That we need to learn when we have these talks, that do you really understand what I'm talking about and what we actually mean? Because when you do that path, education, they suddenly understand. It's no stupid people. It's just, that's not where they come from. And there are, of course, safety-critical functions, which is a piece of software in an ECU, and there is non-safety stuff. The car is mixed with both. And then the way these are developed is very important to notice also. And I take the analogy that assume a function is a movie, you know. And me as a purchasing, I want to buy a movie. I want to buy Modern Times with Charlie Chaplin. What you want, how do you want to do it? Suddenly they build a video player, the hardware, everything for that movie. So at the exact same time when the movie switches frames, they have some magic for it. They limit it to 18 FPS, 1 minute, 23 minutes, and 1 hour, 23 minutes, no buttons. It's made for that movie. If I want another movie, they make another hardware with everything, almost from scratch. If you make the Titanic easier, suddenly it's a color, longer, and waterproof. And it's like they're starting over again, which is perhaps a result of the way safety processes are also formed, and they were forged in an era when big SOCs were not present in cars. It was small MCUs all around the place. So you start to mix these, and you add them in combination, which you had on your left part with safety, and they work together. The problem here is, of course, I would like to play another movie. Sorry, can't do that. We removed color support. We have removed bits and bytes. We don't have that bandwidth because Modern Times doesn't need that. So it's cost optimized till hell. So if you want something new, you literally need to buy new stuff again. So it's moving very slowly, but good thing is it works. It does what it should do. It's distributed. It's resilient. It's robust. So there are benefits with this also, way of thinking. You can literally remove stuff, and it probably still works pretty good. The dependency failure analysis, which is a safety word, is pretty high here. I mean, it's isolation and separation. And where we are moving now is that we want fewer but larger SOCs, whatever manufacturer. The software is literally, it's still a car we are building, okay? We are not building a spaceship. It's a car, it still has a chair, window, whatever, engine, charging battery. That the functions, the software that realize that are moving around a little, and some are ending up in the same, so to say, execution environment. And those are like a video player that can play more movies. Suddenly you have new challenges. I will come to that. You can figure that out. And what's super important is that there is an evolution in computer science, meaning that there is good things coming from having large SOCs. You can do more compute, you can process data faster, you can have more, call it frames per second of your perception, which is good, since the car moving 2 tons. You really need a good world model view of the car. Cameras, new sensors can be used to enhance driving assistance. So these new innovations that comes in adds value to safety also. It adds features that can save lives in a way that was impossible before. But then comes the dilemma. How do you still manage to have a great level of safety in all products we do? And the balance is, are we too fast and furious? It's so cool, and then we mess up. Or we are too conservative and lack or miss the possibilities that comes with newer SOCs. So we need to make sure we can merge these two. And SDV is an excellent example. ELISA is doing an excellent work. I mean, Philip Arman, who was here last year, is doing a tremendous amount of work. I mean, we are moving forward, but it takes time. We are what you said also, Daniel, that what do you want? What do I have? I will come to that also. It's very unclear. I think that's the dialogue we need to have. OEMs, suppliers, communities, you name it. I just need to highlight everyone. I am not a safety engineer, okay? I use that INSA. So you know, so you don't take me for the word of everything. But I will still try to explain how it works. There are various safety protocols or processes that one needs or should follow, and one of them, the most infamous or famous, is the ISO 26262. Do we have Esther here? We have people that works with these standards and works with extending them. I will come to that. But at the end of the day, it's about to provide evidence that whatever you create, the solution you have, is with sufficient integrity, fulfills your safety goals. What is a safety goal? For an airbag, safety goal could be don't deploy unintentionally. That's a good one, right? And you mentioned brakes, work when they should, and don't brake when they shouldn't brake. Goals, and you have a shitload of those. You need to work with those, and those make sense. You can't remove that from the equation. How you mitigate the hazards you identify, that's engineering work. And I can't say anymore. How do I mitigate it? How do I monitor it? We don't talk about Linux here, but we want Linux to be entering. Linux should not take care of all safety mechanisms, for instance. KISS works perfectly fine in the Linux kernel. It should work here also. Keep it simple. And that example there is a way to identify a hazard. What is the severity of a hazard? It goes from QM, quality managed, which is literally know your shit, but it's no safety, to D, which is ASIL death. I don't know if that, but that's what it literally means. The hazard is extremely dangerous. And if you would take the airbag here, probability of exposure would be you sit in front of the airbag all the time in the car. It's 100%. It's always there. It's just, I don't know, half a meter, a thermodynamic load, so to say. Controllability, if it deploys, yeah, and the severity of failure, you will be probably knocked out. So it's dangerous. D, it will end up as D. Some things end up as B. It happens not that often. It only happens if you drive fast. If an ADAS system cannot make a good decision, you limit the speed. Or you do things to mitigate the risks. And that's how you work with safety, usually, from a high level. And it's about evidence. It's not a prescriptive standard. It's about to get evidence to your safety claims. You can hear him scream evidence, right? And clap the hands. And that's the case with it. It's an evidence-based standard. It's not there to kill you, select something, you only have to pick that and that. It is to help you to accomplish some level of integrity in your system. So it makes a lot of sense. What's happening now? Are you here, Esther? No. Oh, no. So, well, she is one of our representatives of Volvo Cars in the ISO standardization organization, ISO 26262, from Sweden. There are different countries. Each country has its delegation, and everybody has a saying. A thing that is happening now is that a pre-existing software element is kind of, how do we make use of those? Because today it's not really part of the standard, which makes everyone believe that recreating everything from scratch is the best thing to do, because that's what standard says. You and I as engineer might think writing a new Ethernet stack is probably not the best thing to do every time you want to have a video player that streams video over Ethernet. So there are ways, this is ongoing, it's work in progress. I don't know when it's ready, in a year or something. It's good things happening here. This could allow Linux to enter more legally, so to say, or regulatory, or following the standard. And for these complex systems which we are building, and when we enter a big system on chip, it's like statistics might be a thing that we might need to allow as proof or parts of the proof that the system works. Previously, it was said similar things like, since a test cannot cover all test cases, you can't use tests for validating a complex system. Then my question is also, and I would like to have Esther, but she's not here, that, okay, what says that documenting things makes it safer, you know? Or that you have thought of every possible problem ahead of time makes it safer? I'm leaning towards both, you know? You should do your work in systemization, yes. You should also test it extensively, not just rely on documents. Documents are nice, you need them, not saying you shouldn't. You also need more in these new complex systems. We know fuzzing adds a good deal of bug finding, even if for a unit test in Rust it might not give that much. Fuzzing and chaos engineering would give much for the system, as in, let's remove this, let's add noise on that cable, let's cut the cable, let's do things. What happens? Resilience, robustness. So it's on various levels. You still need to add that kind of unexpected failures. Those are many, trust us. And why not add Rust for this specification? I know C, C++ is there. Why isn't Rust there? So perhaps that's something that is ongoing. I need to quote Lucas Boulvan. I think he's in ELISA now, right? You guys might know better. He was BMW before. I think this is a quote from when I had this talk first time, 2017. I have it every time, just so everybody knows. The difference between safety-critical Linux and normal mainline is the way you use it, what you do with it. When does it fit into your safety analysis? If it fits, it fits. If it doesn't, it doesn't. Nothing says you can't use Linux. So how can we make way for Linux easier? And one way, which I noticed when I'm moving around in the corridor, so to say, is that we better start with what we want. Having a generic high safety magic ether, solving every problem in one place is hard. You want that, I understand that. If I talk to people, yes, I also want that. The perfect machine would be perfect, but that's not how it works. So we should limit the scope. And I like Elon Musk's attitude here for the design process. I think it's a link here. We can look at it later in the presentation. First step, make requirements less dumb. It's super important. It all starts there, what you want, and then it trickles down into impossibles or possibles. And this is very important if you then have, call it a mechanical engineer writing requirements in a software domain. Requirements could be sometimes vague or very out of the blue. Things that we as a computer science engineer think is easy, they might find difficult. And they might want, I want this part to do the right thing all the time, okay? All the time. That requirement was a bit hard. I don't know, I can't really fulfill that one. So you need to understand them. That's very important that when you're the community, get stuff as whoever supplier. Whoa, please know that sometimes the requirements come from a less computer science aware mind, meaning that I think we should at least iterate this. And this is what I want to open up that people need to do. Not just, I want this requirement. It's very common in automotive. Tier 1's always supplied, and people always wanted. They got comfortable, then they ask for stuff that is sometimes very hard to realize. It's a dumb requirement just because I want it. You need to rationalize, why do I need it? And usually everybody wants a horsepower. This is what everyone wants, right? Yeah, nice. And some industries start like from bottom up. You have tier 1s. Suppliers usually start from bottom up in the sense that I know how SOC works, I am familiar with 5 operating systems, I know exactly DMIPS, TOPS, megahertz, gigahertz, megabytes, whatever, perfect. You know about a lot of technology, how it works, how to build it up. It could also be the department of a platform team in your own organization. It could be different companies, same companies, people in various parts of the system that perhaps don't know really what I want, I know how it works, but what am I going to use it for? But they are cool engineer guys like us, so it's very fun to make up things. I want more, everything, it's cool. Look, I can blink with stuff simultaneously, it's very nice. But at the end of the day, you really want to know what you want. Then there is another group of people, which is usually the more classical automotive persons, or what we call function teams, and note function here is, could be smell in the car, They express what they want. I want this, I want that. And that's okay. That's how you define the product. I want it to feel like that. It's a use case. It might be scenarios. But they don't really know how it works. They don't even know, is it even doable within reasonable time? Or is it something that is impossible? Or it could also be that they think it's hard, but it's, come on, it's super easy. Now we have cameras here connected to a computer, dash cam, and ADAS is not two completely different compute engines. It's actually, I have the camera here, I can do that also. Things are easy, and And sometimes this is combined, you know. Too often, if it's two companies, even within a company, speaking of different languages, sometimes this can happen. Nobody knows what they want and nobody knows how it works, and the project starts. And that's a bad thing. I want to avoid this. And you know, Tux, he can't really do good stuff here. What? How? When? Which? What? Poor guy starts to cry. But this is what we want. And if we manage to get hold of what we actually want to do, Tux can ride this horse. He's happy, smiling more than ever, mirrored, because I want him to look forward. So the first lesson is we need to learn to educate the automotive industry to, well, you have kind of goals, and you know where you are, to settle on a realistic path. That's the first. When that is settled, there is place for Linux. I'm just saying, suddenly Linux can come in here. Oh my God. The next thing, which is a challenge, is a lot of stuff in automotive is developed according to something called safety element out of context. An element here, it could be software, could be hardware, software, the video player, the modern times, whatever. It's safety relevant in the sense that breaking, malfunctioning, whatever, violates your safety goal. The airbag will deploy. Okay, that's not good. And also your context, my context, the automotive OEM, I might be finished with my complete stuff 2 years later. So someone needs to start earlier with the development, because everything isn't just finished year 2. Simultaneously, some work needs to start ahead. It could be SOC developers, it could be software packages, it could be anything. They start in an assumed context, out of context then. And in the assumed context, they do some kind of verification, validation with assumptions. That I assume I am isolated. I assume I don't have a conflict on buses. I assume no one else is stealing my CPU cycles when I need them, so I'm scheduled accordingly and so on. It's kind of bottom-up in that sense. And just because it's tested out of context, will it work in context? In context previously was that you took Titanic movie, a modern time movie, and if you put them aside, only a cable, or if even that was the link communicating with them, that was putting it in context. Now it's like taking two pieces of software in one execution environment, putting them in context. It's a bit more difficult. Luckily, there's things called system safety manual, where it's like in medicine, you know, you buy aspirin, you get this, you can only take 3 per day, put them in your mouth, and don't more than 10 days, don't mix with alcohol. So it's like a manual for putting that aspirin in your context. It's similar with these kind of things, that there are guidelines, rules when you put a piece of functionality into a bigger context. Describes, but safety goal was out of context. You can develop an airbag alone, but when it's a system, it's depending on things. So you might describe, how do I integrate this correctly? What do I, as an integrator, need to consider when I put out of context, in context? My context is perhaps different from the others, so it means that the requirements must match. This is a tremendous amount of work. The bottom line, start early, is actually the most important. Also, assign safety professionals. There is guidelines how to do this, so it's not, Eliza knows this pretty good. Treat assumptions as requirements. I mean, they are literally the hardest requirements you have. If I want the window go faster, slower, that's an easy requirement. This is a harder requirement. Deeply, early, take them into consideration. That's how you do it. And my experience from this was, safety manuals, was that when I started at Volvo, I didn't know about this. I came from Intel, did computers, laptops, tablets, Chromebooks, Android stuff. So I sat in a meeting with French guys talking about the Infineon Tricore. Good, I want to listen. I'm familiar with those ecosystems. They talked about features in hardware and everything, and then suddenly they also talk about this guy. I thought, system safety manual. I thought, what is that? Who is system safety manual? Who is manual? I actually asked that my colleague. No, it's not. It's a manual. Yeah, okay, sorry. So we all should know this is not the system safety manual we are looking for. It's scaringly sometimes we end up here, but it's not him. Because B. Acil B, he will kick his ass. Acil B happens to be I don't explain more. So if you have this one perspective, putting things in context, easier, not easy, easier, emphasize on that. You can skip the microkernel, monokernel thing. It just shows that regardless of monokernel, unikernel, or monolithic kernels or microkernels, it's the same amount of code that needs to run in your system anyway to make it work. So it's like a syntactic sugar mostly. It's like you have one pill. I know how it works. Now comes the challenge that things grow out of proportions, and you suddenly start to put a lot of things into context here. How am I helped by this? Putting this into context is like when a doctor prescribes 5 pills for you. Those 2 in combination will kill you. Those 2 you should be careful about. These might create a completely new effect on you. And each of these individual pills are FDA approved. Legally, liability-wise, everything. And none of these individual assumptions or liabilities, don't take, you mixed it with that one. I wrote in the safety manual, you shouldn't add that pill there because then it will kaboom in your stomach, So that's up to us and the integrators. As an OEM, that's me, or Volvo Cars. We need to put a lot of these, and don't expect everyone to take accountability, liability for others. It's you, it's us. And that's a huge challenge when you start to put more things together. Challenge is what I write here. It's like interaction. We call it dependency failure. How does it interact? Freedom from interference. Common causes, single point. The words coming from the automotive world. We need to consider a lot of this. You have this and you have this guy. This is also an image we had, 2017. The funny part is, the challenge is still there. So the devil's advocate here is like, I have documents, I have safety manuals, I need those. Before it was a mechanical engineer screwing it to the ground and connecting the cable. Now it works, But how do you do it now in software? And that's where I'm coming, that I want to promote this strongly. From a developer's or hacker's perspective. And go back to Niels. How can we ensure everyone is safer in traffic? And that is actually to have a digital safety belt. I'm not sorry if it's okay or not, but it's actually the collaborative mindset, which ELISA stands for, which SDV strives for, which SPDX tries to help you with in other areas, small pieces of the puzzle. That this mentality might or will be needed, I consider that at least, for the greater good. Cars are everywhere, we are everywhere, I don't want to be hurt by those. The openness and collaboration between OEMs for commodity parts, that's the case. It's not all software because you have a secret source somewhere. And it's not free either, that's very important. But it's a matter of what I would call commodity. It could be Linux, could be Zephyr, it could be ROS2 stuff, could be Isorix, DDS, Rust, of course. That brings the healthy base as... It's similar in the way that Linux and that ecosystem enriched Android. I mean, Android was a success due to that they didn't have to reinvent everything. People put in their stuff in the drivers and ecosystems, and you focused more on differentiation on top of something that you don't want to spend time on. If I want to do a function, an application, why do I have to think so much about scheduling details or IPC mechanisms? I want those to exist and be used. And the point here is that if things out of context are developed on a similar base, it uses Linux, it uses the same syscalls, the same libraries, the same, call it the middleware ecosystem. Could be, we don't know exactly where it is, that's for us to define and find out. If that thing is collaborative, the function, the thing that does do something out of context is very close to in context, so like gapped bridges. And the openness enables for the integrator to have easier access to source, not all, but whatever source he has, he understands the system, he can measure it, he can do what Julia will talk about, do the scheduling tracing. There are mechanisms here that will help us. So then Tux is happy, he's protected by an open mindset. And he also knows But in a Linux kernel, it's meritocracy-based deluxe in that sense that it's very skilled software hackers that do the integration, because they know that is not simple. It's not simple at all to take different drivers, everything put in the ecosystem, and then finally deliver 6.4, but whatever. And that's important to know. I want this to be something we discuss a lot more. And if common sense and not breaking natural law is not enough for convincing, people to start using say, Linux in the ecosystem of automotive, we have time and money. Perhaps money is something people understand. So we as a community needs to address this from various points, ISO standards, development friendliness. If you can bring money into it, then everybody listens suddenly. I know Linus Valet is not here, but he mentioned that Sony once just picked Linux as a development environment due to productivity. It was directly converted to money. If we as a community can try to materialize this in a more, manager-friendly presentation of some kind, we can suggest this to Philip and others. We should find the good cases where development speed has a price tag. Ability to debug has a price tag. Finding resources, talent has a price tag. The community's efforts, the return of investment, if you reinvest in the community, has a value. Share the burden of commodity has a value. And for me, happiness is the biggest one. I mean, it's unmeasurable, but an unhappy developer versus a happy developer. Who will you want to develop your car software? That would be really awesome. So what I would like everyone to want, is to kind of find this commodity layer. Open source. Bridge the gap between out of context, in context. Then I would be happier at least. Yeah. That's all. That's my take on it. I don't know about the time. Do we have any small questions until we start the panel? DAS panel? Yeah, we can run it there. Okay, so then I can continue about the panel. So let us bring forward a few extinguished guests. Björn, Julius, Linus Valet couldn't join. We have Florian and Andreas. We'll make place for you here. Let me present Björn Töppel. We met him yesterday, RISC-V.
Yeah, I'll be the RISC-V.
Yeah. We have Andreas, talked about Rust.
I'll be the Linux advocate.
Yeah, and we have Julius. Do we have something? Perhaps we can use the microphones here and let the crowd speak up louder.
Yeah, so I'm Julius, and we're doing Rust at Volvo, so we wanted to talk about that a bit.
Yeah.
Hey, I'm Florian. I'm nowadays just a co-founder of Ferro Systems. I used to be part of the Rust project, the core team, and I'm one of the co-founders of the Rust Foundation. So if there's any questions about that confusion, I'm also happy to answer them.
Great.
I take no trademark questions.
And me and Daniel will try to moderate it. So, just so you know, a few years ago, Thomas Gleichner, Gunnar Andersson, and Robert Lagerstedt sat here. The furniture was a bit different. We talked about similar things. Gunnar was a Genevi tech lead. Now it's Covesa. Thomas, we know. So you are like them now. So you feel that you are on that level of... no pressure at all. It was really fun. So we start with RISC-V just as a warm-up. Yeah, and it's a matter of, from an automotive, will RISC-V be something that can enter that scene?
Maybe I can start with start with a question. Maybe I know that NASA and ESA, the space agencies, they have sort of standardized saying like, hey, we want to support a open spec, or the only sort of MCUs or SoCs they want to see is they have to be based on RISC-V because we don't want to be tied into a certain company. So companies come and go, whereas instruction set stays. So
forever.
Which is so I was thinking more like how does sort of OEMs view is that if we take Daniel's was it the left hand side like the small functions. I mean, I know that you want to be able to update all the software, even if it's like a tiny little thing. And sort of standardizing on one ISA would probably be a good thing. And one ISA that's not tied to a certain company. So I guess maybe it's a question for you, Robert. Like, what is sort of does OEMs try to, like, what's your stance there?
It's twice. It's, I say, duality here is that a lot of automotive is depending on the ecosystem that exists today.
Right.
We can't dismiss that. I mean, there's a lot of invested there.
Yeah.
But there is also a lot of frustration in that area. Call it AutoSAR, call it any systems that are used. But they are working well. They come from a long line of evolution to fit the MCU, you know, control loop engine or airbag deployer computer.
Right.
But what is wrong is that development speed is hard, innovation speed is slower. It feels like that sometimes because you can't choose by anything. You need to buy, literally.
Right.
And you can't see what's happening. It's only specs, docs, something works.
So it's really a black box. That
Yeah,
you're
it is
buying.
more or less a black box, which is okay, but if you want to innovate and if you want to have more control of what you're doing, the whole system, openness is actually a factor that I would like to promote in. You don't have to start with the most critical issues, so to say, but there are so many that do simpler stuff that we want to integrate or centralize together, I would rather buy a RISC-V thing there, perhaps, with an ecosystem.
I guess cost-wise that would make sense as well, because you could sort of, I mean, all the vendors, they don't have to, you know, provide their own tooling. Like, you can use the open source ones, and it's, so maybe if you sort of could push the vendors to do that, that would be like less cost for them, less hassle for you.
I agree.
Easier to, you know, you can actually take their source code, rebuild it, you know, update firmware, which I guess is probably not the case now because they're using, I don't know, what was it, the tri-course?
Yeah.
No, like, where do you get that compiler? I don't know.
No, you buy something and hope it works. But it's usually certified, it has followed the process for ages.
Right.
So it has the stamp, you know. I'm happy. So the question is, I have a question. Hi, Astrid.
Can you please use the microphone?
Oh, I'm not. Hello.
It's not close enough. Did you hear him anyway? Yeah,
You didn't miss much.
it's intentional to listen more, And the thing is also that perhaps a smaller MCU is a way to easier enter the automotive in what I would call a non-safety critical first.
Okay, so you would start there.
Yeah, I think that would be one way because that's the user experience feeling of lights, of experience in the car when you enter it, chairs, you know, some comfort.
Yeah.
That piece of smartification, perhaps you don't have to buy, you know, you can help with development. And then to move in the next steps, you might need to have, you know, support for lockstep. Does it support that? Probably it does. You know, RISC-V, these kind of mechanisms that are needed to be certifiable in an automotive world.
I mean, maybe that's a good thing. Like, what is missing? I know that there's a, you know, there's a bunch of automotive, like working group stuff like that. But maybe, like, the OEMs need to push more about like what is missing from a spec.
Yeah, and that is the takeaway for me to bring back.
Yeah.
And we are back on the what do we want.
Yep.
So we get the nice horse.
So if we move up to the course, so I know that, is it Volvo that has standardized on the drive platform from NVIDIA, for example?
Yeah, we use that.
And that's, again, you know, it's one vendor, and, you know,
that SOC uses...
being NVIDIA, it's kind of, I guess, that'll be interesting to see if you can get out of. So.
No. Yeah, that was my next question. Good that you said that, Niklas.
Mobileye uses, so NVIDIA uses ARM, but there are other options that might...
You're right. Mobileye IQ6, I think it is, the newest generation, uses a quite hefty RISC-V 12-core setup as the main CPU cluster.
Well, then, then to be blunt, maybe they were based on MIPS before, so I guess it was kind of easy for them to move over to RISC-V, but hey.
Nevertheless, they're using it. And are the others, you know, like enlightened people with RISC-V?
I know that there's, like Anders, for example, I mean, a lot of vendors that, you know, try to sort of sell to the automotive folks. But I think that's sort of that's coming from the other side. Like they want to get into the automotive industry, and they do RISC-V because it makes sense for them and it's price efficient. But I guess for it to take off, I guess that maybe, I mean, it should be the OEMs that sort of say that we want RISC-V, for example, because it makes sense for us.
Yep. They're good.
For various reasons.
That's a great takeaway.
Yeah.
Do we have any more RISC-V questions here before we move on to Rust? No? Yeah, one. Speak up.
It might not be completely RISC-V, but still RISC-V to the room. But one thing is the CPU. But what about all the other peripherals you put into your CPU?
Exactly.
Controller, RISC controller, PDR controller, whatever it is. How does that fit into a safety point? One thing if I can take the CPU, but if everything else is my MCU or SoC is broken from a safety point, I also don't have access to.
Yeah, exactly. So probably that's a good point. I think it was Jesper that talked about. Is he here today? Anyway.
Which what?
No, anyway, we're talking like what's missing in, like the ICE is one thing, but to your point, like, that's probably not enough for someone to switch. I mean, sure, the ICE, but it's, I mean, really, it's the IPs and all the rest, like, debug environments, tracing, whatnot. So maybe, the ICE is the smallest parts. So maybe we need something that's standardized or, open specs for that as well. In the automotive industry.
But then we're in the domain of interacting with a GPU vendor or with an I/O or with whatever accelerators you put in SoCs. If you make them bigger, you're absolutely right with the question that the CPU cluster, if in any architectural lithography, of the blueprint of a SoC, the CPU cluster is a pretty small piece on that one.
So maybe that's a good point, and maybe that's sort of the barrier for entry. It's like the ICE, like no one cares. Like we can do, Synopsys or whatever. It's the IP that actually is important.
So for the sake of moderation, thank you for the RISC-V part.
For the monologue.
Yeah, no, but it was. I hope that you find it entertaining in that sense, and try to move towards for Rust, if it's okay. Yeah. And I thought actually that Julius, there is a good article which we wrote from Volvo interviewing Julius about the project we are running internally with Rust, Arctic. You can say a few words. Just to introduce that.
Yeah, sure. So I joined 2017, a bit after Robert, and by that time I was already sold on Rust as a way forward. Had been debugging way too many memory issues before that, and 2019 we were able to start this project. It happened to be the perfect testbed for introducing Rust into our product because it was a platform that was supported. It was not safety critical, so we didn't have to worry about that because that didn't exist at the time for Rust. And and it was a fairly small system, so it would be fairly easy to contain. And so it's a small microcontroller based on Cortex M4. It's used for the low power case, so every time the car is parked or not in use, it does most of the, or many of the functions, most importantly to wake it up when the driver approaches. The reflection so far has been that, it's been basically above expectations in every aspect, I would say. The problem is that we only have this single data point, so it's hard to say if it's actually Rust that is the issue, or is the main factor. But my intuition is that it's a huge part at least. I mean, we are seeing lower inflow of bugs compared to comparable teams. We are seeing much more happiness within the developer teams, our team. Something that I didn't realize before, but something that I take as a huge strength is that onboarding new members into the code base is also much easier because you have all the support from the compiler and the test infrastructure and everything so that the newcomers can play around without being afraid of messing things up in a completely different way. So that is a huge bonus. So all in all, it's been a huge boon, I would say. And now we are looking into ways how to expand it further within Volvo. There are already a lot of teams starting to get their eyes up and showing interest.
That's great. That's great. And I think it adds safety in this sense.
I think it would be really great to have some kind of cross-industry statistics because, as you say, it's your gut feeling that you move faster and people are happier, and that's my experience as well, and that's what I hear from my peers that adopt Rust. But I'm still lacking,
Yeah, the hard data is missing, and that's also kind of before because we're lacking time machines. I mean, if we could start the same project again on a separate timeline and measure, then we would have something. But unfortunately, that's not possible.
Well, that's actually one of my love subjects. One of the reasons why the Rust project runs a survey, I kickstarted that, is literally data about programming languages is completely missing, and it's a research field. So you can read the body about adoption of programming languages and what the reasons are in about a weekend, the research body. And one of the reasons is that no one's willing to share their data. So we have the thing with Microsoft, 70% of our things are memory safety issues, whatever. Try to get the raw data, you won't. Google, you won't. ARM, you won't. So we can talk a lot about open source and programming languages and all of these claims, but Julius saying this is my intuition, like no one else knows better because no one's willing to share. And that's a problem for us as implementers of those programming languages because we don't get access to the data of the effect of our tooling because it enters their places. And the interesting thing is the little piece of research that we have actually points to pretty interesting results. So for example, one of the main reasons to adopt a programming language is quite literally popularity. That all the type system things and so on and so forth don't matter. And we are trying to set up a study around that. Anyone who wants to give data points, please let us know. But I just want to highlight that that's a problem even for implementers. The thing that the running surveys has fixed is Go and Haskell and all those languages have now at least started to have their community polls so that we can at least compare between the languages. Like, is any of the languages doing better in a certain aspect or not? But yeah, it's a huge problem. Thanks for highlighting it.
Yeah, and within Volvo, we have been trying to gather like hard data so that we can show that this is actually better, and we actually have some data that supports that. But the problem is that none of the other projects are directly comparable. So it's and there are also other factors that might be contributing to it. So we and given that it's the only project, it's hard to say. But as soon as we have more data points, we can start making some assertions on that part, I think.
Yeah. And I think we shouldn't take for granted what we feel. It's better. It is, you know. If it's not quantified in a way, others understand it. And I think about non-engineers. It is my take on where I am being is that it's utterly important because that's what literally we are being chosen away from. Like, you know, 2 or 3 managers think Rust is Rust, you know. They say no, and they sit on a board with a voice, with a vote. We need to work that problem to find the metrics. If we have, I think we, if any, could provide that. And Andreas, if you want to add.
Yeah, I have a little bit to add to that because when we are trying to bring Rust into the Linux kernel, we are facing a lot of really busy maintainers that don't necessarily have the time to pick up Rust to be able to maintain the Rust code. And these maintainers are really busy because they are reviewing a lot of code. Yeah. And I think, like you just mentioned, onboarding and getting people started is much easier because the language is really helpful to get speed in the development. Yeah. And I think one of the reasons is that you spend less time reviewing because the compiler is doing a lot of the review for you. Mm-hmm. So I think like in an ideal world where we could snap our fingers and turn a subsystem into Rust, we would probably see that the maintainers would have more time to do work that is not reviewing code for safety issues, for instance.
Yeah. And that could be actually an incentive for them to do it. Less time spent on finding pointer errors. Yeah.
You say something, Any questions from the audience now that we have this? Yeah, sorry.
One parameter that I think is really important in all of this, you mentioned popularity, is academia. Do we know what they're teaching in universities? Mm-hmm. Have we seen an uptake of Rust? So when the 22-year-olds come out of university studies and start looking for jobs, are they going to start asking for jobs that include doing programming in Rust? Mm-hmm. Actually, and that's kind of my point. It should be something we should push our academic friends.
The answer to that is, so I don't have any hard numbers to back it up, but so this was also something that came up at the LSF a few weeks back, and actually the maintainers are, so now what I say is my experience of the world, and if someone has a different opinion, please raise the point. I'm not trying to lie to anyone. But someone was saying that it's the same people that show up to these maintainers conferences year over year, and they want to get new people in. And someone was saying that all the new kids are learning Rust in the university, and they want to use Rust because they're really happy with it. So maybe there is something to be gained by adopting Rust, because we can acquire all of this new talent into the project.
Yeah. I can highlight a couple of things there. The Rust project actually has very good relationships to academia. Like, I've seen Miri on the slides. Miri has been developed at the University of Saarbrücken. And they do all the research bits that can be actually upstreamed, they do on the upstream project. So the Miri maintainer, recently he got his professorship at ETH, I think, is actually part of the team. The ETH Zurich is doing a lot of things more off it. And I've been teaching university courses since 2017. It's small, but there's already an initiative called Rust Edu, which I would like to highlight here. If you have any questions about Rust in academia, they're the right people to answer, because they are the community effort and I think that's the other thing, making sure that people that have a certain interest, like a professor wants to run a course, it's good that, for example, you have someone who already has a set of slides to share. And in Germany, that has actually happened. There was a university student in 2016 that did a course that made it available everywhere. Essentially, every university that runs a course has a piece of that slide deck, which incidentally is one of the reasons why I'm rooting for make your teaching material open source for people to remix rather than making it copyrighted.
If you're in it for the long game, go
Yeah.
for the kids. Yeah.
I'm curious about how easy is it to find employees to work on Rust?
Yeah, and so that's the interesting part, that actually none of our team members knew Rust before. So they all came in with granted, a lot of C and C++ knowledge. So they picked it up quite fast. And the thing I was mentioning earlier with the onboarding process being easier was that they knew systems programming. They knew like how systems work and how these embedded things work and all that. So they could experiment in the code base without any fear, I would say. And they can't tell you exact numbers, but 3 or 4 weeks or something, and then they were basically on average. We had one who was already cutting releases after 2 weeks, but he's a bit different.
That's impressive. We had a question from you in the green shirt, if you want.
Could I get a
Yeah.
Or then
Throw that.
He was already running, sorry.
So hi. So my name is Vasily. I'm a student of physics. I have a question that's not very relevant here. It's more theoretical. It's more like computer science and my thinking that might be a bit too naive, but and it's a bit out there also, very theoretical. Like I was thinking about compiler backdoor attacks. so this is when you think you can trust a compiler, but it does something with the machine code. So when you now, I don't know how easy or hard it is to mitigate this in reality, but it's an interesting concept. So now that there is AI that is very language capable and becoming more so, and also by extension code capable, and can output in principle anything from machine code to higher levels.
Yeah.
Like what I'm just thinking that what ways is there to not lose, like the essence is not losing control over the machine code, not losing trust and control. What ways is there to basically.
Yeah. I don't know, Florian.
So first of all, trusting trust attacks have been executed, also practically. There was an attack on Xcode where people, like through a manipulated download, would replace the Clang compiler, which would then link I think it was in the Bitcoin miner times, would link in a Bitcoin miner into smartphone apps. So yes, that has been done. I can also share, as being part of the community team, that companies have approached us about whether we can shave off 1% of each compiler run for Bitcoin mining. I mean, the Rust compiler is not the fastest, so it wouldn't show up. The thing here is compiler safety is actually a big topic, and one of the things that I like about the Rust project, even though I was a core team member, I never had any merge rights or infrastructure access. The infrastructure access, because Rust comes out of Mozilla and Mozilla runs a really tight ship, is essentially similar to Firefox. There's only a very limited amount of trusted people, and everything else works to automation. And that's actually something that's very similar to the practices that, for example, companies like Volvo do. It's like, make sure that all accesses are safe. Your question about AI, I have not seen AI-based optimization chains yet. I wouldn't be surprised if we see one or two of them in the next couple of years, and I think then the problem becomes legit. What if we can't understand our optimization chains anymore? On the other hand, I have to say, compilers are a pretty volatile technology. So for example, if RISC-V adds an extension left and right, people add optimizations left and right to make sure that those extensions don't have to be exposed to user code. Optimizations are also essentially an interface towards the code. And this is a problem that in safety critical we're regularly running into. So for example, there are optimizations that are not guaranteed by the Rust language or C or C++, like for example, auto-vectorization is a classic that you change a little bit of code, your optimizer doesn't fire, suddenly you have not vectorized code, which suddenly runs past a deadline if you're in a real-time system. So what I know in avionics, for example, the big hammer around that is that many small avionics systems are actually read after compilation. So you take 20 people, 2 people per piece of source, and you read assembly for making sure that you don't need to trust the compiler. One of the core things in avionics is the compiler is broken. It's such a huge piece of technology, it's certainly broken. You need to prove me that the artifact works.
Yeah.
And that's actually a pretty fun problem to deal with. And Rust helps you along the way.
Talking about the learning curve, to get into business.
I can say it's easier to learn Rust than to read custom assembly for a custom core that's under Rolls-Royce jet engine. Yeah. Okay, enough fun about that.
I have a question for you, please. So keep the mic. Okay. Ask you. So how does it work with tool chain wise? Has Rust adoption been affected, like the vendors, if you buy a SoC from someone? Is the tool chain something that you expect them to deliver, or do you, like you as Volvo, do that yourself, or how does it work?
Probably going forward, we would expect that, but for this project, that didn't exist, and I think still the SoC vendors are lacking. So I've heard rumors that some of them are actually starting to look into it, but yeah. So hopefully that will be the case, that you get at least these base HALs and these base lowest layers available, similar to what they have in the C domain. But so far we actually wrote all our drivers ourselves. So we are members of this ATSAMD community that is the driver package for our chip, and we have mostly contributed. Yeah, so it was like 30% complete when we started, and now it's closer to, I don't know, 70 or something.
So it's more from just doing a Rust up and getting a upstream toolchain, in other words.
Yeah, no, now it's
I was
that
thinking
way.
more about the toolchain than like the Rust.
Yeah, okay, the toolchain we've been using directly out of the box, open source,
Okay,
everything.
so
that we have.
So the days when you actually had to get a compiler from your.
Yeah, and that was also the reason why
vendors.
this was a good project to start with, because we already had platform support in the open source compiler, so we could just.
Gotcha.
Just to guard the time, Hans, what is timing? Yeah. So before we end this dialogue, do you want to bring up one more thing? You feel that I really would like to say it. Anyone?
I would like to hear more about the certification effort.
Yeah, if Florian has something to say, I think that could be a good ending of how progress has been.
Okay. Yeah, it's been a little bit of a long thing. So as was hinted, we're currently on the last legs of qualifying the Rust compiler. So documents are at TÜV, and we're waiting for the final documents are at TÜV. We've been working with them for 2 years. The interesting thing about it is, we got funding by an OEM for that, and they allowed us to take the very long route. Rust famously doesn't have a specification, which for us means in automotive we need a requirements document. We wrote a whole Rust specification, so there is now one. And there's currently discussions within the project whether to actually adopt this, so this may change. And then we needed to do the whole work of actually tracing how the Rust compiler actually implements the specification. Specifications come in many versions, so this specification is just descriptive. It says this is what the Rust compiler does, and we need to make sure that both of these match. The interesting thing along the way is that we found that we did not have to add test coverage to the compiler. So it's already very thoroughly tested. That's actually a good message on how much that effort is. The other thing we observed, though, is there's a lot of people just waiting for that to be done, and that's not how it works. It's actually a major effort for 10 to 15 people, and we're only half done yet, because now comes the thing that you talked about, platform support, all the libraries need to be validated, all of these things. So just because the compiler is there, there's still a lot of things to do. And one of the things that I observe is there's both an opportunity and a problem here. Programming languages are not moved into new environments very often. I mean, we're seeing it in Linux. Linux is currently adopting its second programming language, if you don't make a programming language and things like that. And that means there's also not a lot of experience in the companies of what that actually means. And so we're talking about, for example, a SumIP stack with an Eclipse SDV. But something that's ignored is, from the perspective of someone who builds a programming language, the first thing you start with is, okay, we have integers on the processor, we have floats, we have memory allocators, we have simple abstractions like vectors and things like that. And it's a very hard thing to make people aware that before they can build things like, they can build things like SumIP, but before they can start putting that on cars by those quality levels, they need to cover that gap essentially. And the last thing it runs into is, if you don't have people that are aware of that, there's no budgets for this, because essentially there's no budgets for things that people aren't aware of. And that's not a problem, because why would you have that? Or not an inherent problem, but that's one of the parts that we're currently struggling with. On the other hand, we're more than positive, given that this becomes such a big topic that quick, that this is going to resolve itself in a way. The other thing that we're currently looking at, so if someone here is doing these things in an academic fashion, we would actually like to also make sure that we can maybe make a step up over how C and C++ libraries are validated, and comes back to the point now mentioned, maybe having academia on board could also make these things easier. Yeah, it's my Rust 5-minute thing. Please feel free to chat.
And thank you very much. I think we need to end here. We have lunch. It starts now, and we have a session with Julia starting 13:30. And I would like to thank you guys for being here, sharing your wisdom.
Thank you.
And give them an applause.
And thanks to the organizers for running this thing.
You're welcome.
Thanks for having us.